Hi guys, in this video we are going to see our first application of OPAMP, the very basic application of OPAMP. In the previous video we have learned about how an OPAMP performs. So if you haven't watched those videos, I have given the link in the description so you can always watch that. So without any further delay, let's look at this session. And also if you are new to the Expert Tutor channel, please don't forget to subscribe it. Okay, so here we need to understand, we are going to look at how an op-amp can be used as voltage comparator. And also in the previous video I have already mentioned, this is going to be known as, here we are going to give two inputs, V plus and V minus, and two power sources, plus VCC and minus VCC, and the output we are going to get from those things. And also this V plus, this terminal is known as non-inverting terminal. So please note this term, it's going to be known as non-inverting terminal. So you need to remember that. Likewise, we are going to tell the V minus or V2 as inverting terminal. You will see the reason in the upcoming videos. So here you need to remember these two terms. As we have already seen, V naught would be equals to AVD, a constant. Actually, theoretically we will consider as it's like infinite, but it's going to be a constant actually, into the differential input voltage. The VID simply means V plus minus V minus. So V plus minus V minus. So here you can see that V naught is going to be equals to AVD into VID. But let's see, if the value of VID is higher, in the previous video also we checked that if the value of Vig is higher, we will take that according to this equation, we will take that V naught is going to increase proportionally because of AVD is constant. But we have learned V naught cannot be increased for after the certain limit. That limit is going to be Vs, the source voltage, or you can write it as VCC. Here we will mark VCC, but here I haven't marked. Normally we will mark in this side. This is going to be VCC minus VCC. So it can only increase up to this V source, or else you can write it as VCC plus VCC. If the VID is in the plus, let's say VID, we can actually denote it as VID is equals to V1 minus V2, and V1 is greater than V2, the VID is going to be positive. You can directly tell that. So if it is positive, we are going to get an output of positive voltage, but although it's having a linear equation, but it can't increase after a set limit. That's going to be plus Vs, plus of that voltage, source voltage we are providing. So let's say if you are providing V plus, which is far more higher than this V minus, let's say if it's actually the V minus is 1 voltage, let's assume like that, you are providing V plus as 2 voltages. So the VID is going to be 2 minus 1, it's going to be 1 voltage, it's going to be plus, actually 2 minus 1, it's going to be plus 1 voltages. If you put the value over here, you are going to get, this is, let's say this, assume as the AVD is 100, so plus 1 into 100, it should be plus 100 voltage. But let's take as we have only provided the plus Vs as 2 voltages, or let's say this is as 3 voltages. We are only providing with 3 voltages. So the voltage, output voltage can be only reach up to 3 voltage. So even though theoretically we need to get 100 voltage gain, but we are going to get only 3 voltages. So in this thing, you can directly mark it like this. So if this is a graph and you are providing 2 voltages for V plus and 1 voltage for V minus, if you provide like that, you are going to get an output which is going to be 3 voltages. Likewise, let's consider in the next way. You are providing the V plus as, let's say this is -1, and you are providing V minus with 1 voltage. So what going to happen? What's going to be the output voltage? Please pause the video and try to figure it out in your own. I hope you have tried that. So here we are going to same thing. V1 minus V2. V1 here we are having -1, and minus V2 is already plus, so you are going to minus this one. So here we are going to get the VID as 2 voltages. So theoretically we need to get -2 voltage into that AVD value. It's going to be minus 200 voltage. So always remember there is a minus. But here we are only providing -3 voltage, as let's assume as -3 voltage. So we note the output can only reach -3. After that, it can't increase that voltage in the negative side. So the maximum voltage is going to be -3 voltage. So when you are providing with V minus with 1 voltage and V plus with -1, you are going to get the V output as -3 voltage. So that's the simple idea. If you are giving the V plus, which is as higher than V minus, you are going to get plus. It's going to be plus Vs. If you are giving V minus higher than V plus, you are going to get Vs minus Vs as output. So this is going to be output. So here you can easily figure it out. It's known as voltage comparator. We can compare the voltage between any 2 points. Let's say if you don't know the voltage between 2 points and you need to figure it out whether that voltage is higher, which point is having higher voltage, you can actually connect these two ports, these two terminals, and you can check the output. If it's plus, you can tell this port, the V plus, is having a higher voltage. If the output is minus, you are going to tell V minus is having a higher voltage than V plus. And also we can further develop this as zero comparator. Zero comparator simply means if we ground this V minus, let's say you have ground this, actually we knew if you ground anything, the voltage would be 0. So from that, if you are giving some voltage for V plus, let's say you don't know the voltage but you need to find whether it's going to be minus or plus, you can actually give that voltage to V plus and check if that output is showing plus Vs. We actually knew that the V plus is higher than V minus, and also we knew V minus is 0. So V plus is going to be positive voltage. So you can, if you have any doubts whether that port is having plus or minus voltage, you can simply ground one terminal. Like it would be easy if you ground minus terminal, and after that you can check with plus and also with minus, whether it's plus, whether it's positive or negative. And also if you want to check whether the certain voltage or certain point is having more than 2 voltage or 3 voltage, what you can do is you can provide the voltage. Let's say if you want to check whether one point is having 2 voltages or more than 2 or less than 2, so what you can do is you can simply give 2 voltage for one terminal and you will provide that point to another terminal and check whether the output is having plus or minus. From that you can decide. This is known as threshold detector. So there are mainly 3 types of things, so you need to actually know how they are working. So it's very simple concept, voltage comparator. So this is working on very theoretical manner. It's also, you can easily use that for comparing any voltage of unknown points. So I hope this video would be clear for you. In the upcoming videos we will see more application from OPAMP. Until then, see you later.